We are looking at question 17 from the in-class work in sections 1.4 through 1.6. Question 17 asks us to solve the radical equation and to then check all proposed solutions. So in order to solve a radical equation, we want to isolate one of the radicals, and the process is going to be to raise both sides equal to a power that is the same as the index on the radical. And then we want to, simplify. And this is an iterative process. So that means we're going to do it as many times as necessary until there's no radicals left and we know what x is proposed to be, what the solutions are. And then we will check those solutions because this process can lead to extraneous or solutions that we must throw out because they are not true solutions to the equation. So what we're going to do is we're going to pick a radical first to move. Now, when I do this, in this case, we have the square root of x plus 36 minus the square root of x minus 20, and it's equal to 4. We want to isolate one of them. We want one radical by itself. I'm going to choose to leave my first one because by adding the square root of x minus 20, I'm going to have some positive signs, which I like. Less to remember, less to carry, and less mistakes that I may make later. So on the left side, I am going to have x plus 36 under my square root. I have canceled out or moved the square root of x minus 20 to the right, which leaves me with 4 plus the square root of x minus 20. Okay, so when we get here, we are now going to look at the radical we isolated. And we isolated the one on the left. This is our square root, which has that understood index of 2. So in order to remove it, we're going to raise this side to the second power, which will allow us to cancel these two things out and leave me with x plus 36 on the left-hand side. Whatever I do to one side, I must do to the other. And when I do it here, we need to be very careful because this isn't 16 plus x minus 20 or something. You have to expand this. This is a binomial or a two-term multiplication, and we're going to multiply it by itself or square it. So we should get out an expression that originally has 4 terms. We may need to combine, simplify, so on and so forth. But initially, it's going to be a 2 by 2 multiplication, which will result in 4 products initially. So let's go ahead. On the left side, we will leave my x plus 36. On the right side, I'm going to give myself some room because I know this is going to be a lengthy process. I'm going to start with my 4 by 4, which will give me 16. Next, I will multiply. Let me get some colors here. I like colors. Let's do our 4 by the square root of x minus 20. The 4 is going to go in front. 4 is not under a radical, so it's going to be in front, multiplying that radical. And similarly, when we multiply by, I'm just picking some different colors here, square root of x minus 20 by the 4 on the other part, this is going to also, this 4 is going to be in front, multiplying my radical. So it's going to move to the front because the 4 is not under a radical. So you're not going to push underneath there because it's not under one to begin with. It's just going to be in the front, multiplying the radical. And then for the last one, I'm going to explain this a little bit. So I'm actually going to kind of do this off to the side just to kind of show you what's going to happen. I'm going to multiply the square root of x minus 20 times the square root of x minus 20. I'm just going to kind of bring this down right here. We're going to talk about what's going to happen. So when you have the square root of x minus 20 and you multiply it by the square root of x minus 20, you're really taking the same value and you are... you're taking it and you're squaring it, right? Well, just like when it canceled up here, the square root and the square root here are also going to cancel. This is just going to leave me with my radicand, the value underneath, the x minus 20. So I just wanted to show you this kind of like make sure that everyone understands. So I'm not going to show that multiplication again there. What I'm going to do is I am going to jump down and write, they're both positive, so it's going to be plus x minus 20. I'm going to leave this work here just so that it's there. But I will go ahead and bring down on the left my x plus 36. Now on the right side, I'm still operating up here with my 16, my 4 radical x minus 20, my 4 radical x minus 20. I have an x and I have a negative 20. I want to identify my like terms. So I'm going to start with my constants, my numbers. I have 16 and I have a minus 20. 16 minus 20 is going to give me negative 4. Next, I have, let's get a different color here. We'll do some radicals. I have 4 with the square root of x minus 20. I have another 4 square root of x minus 20. What we do, these are what we call like radicals because you have the same value underneath, the same radicand. You have the same index because they're both square roots. They have that understood too. You're going to add the 4. So that's going to give me plus 4 and 4 is 8. And you leave the radical alone. Very much like if this were a 4x and 4x, it'd be 8x. Think about it in that similar way. And the last thing that I have is this little x here is by himself. He's going to come down as well. Okay, so I squared both sides. I expanded and multiplied my binomial squared. So where I have this expression on the right. And now I have, after I expanded that and multiplied all 4 of them, I brought down, my left side. On the right, I did go ahead and combine like terms, like radicals. And now I'm going to repeat the process from the beginning one more time. So the process when you are solving for x and it's in the radical like this, where we have this x underneath, what we want to do is we're going to isolate this radical. So anything that's not part of this radical needs to move away so that it's all by itself. The first thing I'm going to move is my x because I like to move my variables first. So I'm going to find a nice color for that. Let's use just a different blue. Okay, so I'm going to subtract x on both sides. That's going to leave me with 36 equal to. A really nice thing that happened on this problem, it may not always happen forever in the future, but right now, the x terms both canceled out. So it's going to make our process of solving a little easier as we go forward. But keep in mind that does not have to happen, and it may not always happen in the future. I still have my negative 4 plus my 8. I'll leave those the same color they were just because I feel like it's easier to see. So we'll make plus my 8 square root of x minus 20. Keep in mind, again, those x's did cancel, right? Okay. Now, the next thing I'm going to move, I'll move my 4 over here to the left. That's going to give me 40 on the left side. And then on the right, I have my radical expression, and it's getting closer. We're not quite done, but we're getting there. I have 8 square root of x minus 20. So the last step to isolating my radical is dividing by 8, which will leave me with 5 equal to the square root of x minus 20. And now, in order to solve this once more, I am going to square both sides because, again, this radical expression has an index of 2. So to remove it, I will raise both sides to a power equal to that index. So again, this had an index of 2. I raise it both sides to a power that is the same as the index. That allows this to cancel, leaving me with x minus 20 on the right. And on the left, I'm going to have 25. Now to go ahead and finish it up, I do want to find x. I'm going to solve by adding 20 to both sides. X will then be equal to 45. Okay. When we get to this point, we do need to go back up to the top and think about what we said. Our original instructions told us to check all proposed solutions. We do need to verify that this solution is correct and that it is one that we are permitted to have. So we're going to take 45 and we're going to plug it into our original problem. So I'm going to come here and I'm going to say the square root of 45 plus 36 minus the square root of 45 minus 20. And we're checking to see, is that equal to 4? Well, here I have 45 plus 36 is going to give me 81. So, and I can erase my little arrow just to see. So I'm going to say that is the square root of 81 minus, I'll erase this other arrow here, and that's going to be the square root of 25. Okay, so like 81 gives me 9 minus 5, so it's going to give me 9 minus 5, and that is equal to, I got very excited about my arrow, is equal to 4. So this solution does give me, it does give me the correct value that I was looking for, and it is real numbers underneath my radical. So that's one thing we would be looking for. If you get negatives, those are not real numbers, so those will not be solutions to this, because 4 was a real number over here. All right, so our solution then is the 45. So don't forget when you get done after you plug it back in, what was my answer? So just make sure, you double check your work and verify that your solution does give you a true value and that it is a permitted value. And in this case it was. So our solution is x is equal to 45, or you could say the solution set would be, 45 in that form.